Horizontal and vertical isomtopes. First we need to know what in the world they are, and then we can talk about how to find them. Now, a vertical isotope is a place where your function is zipping up, say like right here, up to infinity or down to negative infinity. And this happens, we would say, when x is -2. So we have a vertical isotope when x equals -2. We have another one sitting here. Let's see, right in through here. We see that the function is headed both to infinity and to negative infinity. It doesn't matter if they're opposite. They can both be headed both to straight infinity or just one side or whatever. It's still called a vertical isotope. So I have one at x equal to -2 and the other one is at 3. Horizontal isotopes are basically describing what's happening in the end behavior of the function. That's out in this description, right out in here and right out in here. If you look, this function is headed to y equals 0. So horizontal isotope on this one would be at y equal to 0. So it's basically what's happening in the end of the function, or the far left hand side or the far right hand side. We say what's happening when f of x, right here, what is happening to this f of x, and f of x is headed to 0 as x is going to positive infinity. Over in this area we'd say as x is going to negative infinity, my f of x is also headed to 0. It's headed to 0 from the bottom side. This one's headed to 0 from the top side. Alright, now we've looked at a graph, so let's go figure out how to find these things. We're looking specifically at vertical and horizontal isotopes of rational functions. And what a rational function is we have some fraction, and I know this is crazy looking, but we have some fraction. We have x's in the numerator and x's in the denominator. We're going to say that n and d have, the numerator and the denominator have no common factor, so I want it simplified as much as possible. And then I have some x's up top and on bottom. Then we're going to discuss a vertical isotope. The vertical isotope would be where the denominator, or this little section right in here, equals 0. So how you will find this is you'll set the denominator to 0 and you'll just solve for x. Alright, so let's just look at, say, f of x equals 2x squared over x squared minus 1. Set the denominator equal to 0. X squared minus 1, where does e equal 0? Factor that bad boy. Hopefully they'll factor. If they don't factor nicely, you might have to use the quadratic formula, which is always big fun, or factor by grouping, or one of these other methods. So I have vertical isotopes for this particular one at x equal to -1 and +1 for this particular function. For the horizontal isotopes, you're going to compare numerator and denominator degrees. And then you have 3 cases that might happen. You might have the numerator degree is greater than the denominator. You might have that they're equal, or you might have that the numerator is less than the denominator. We're going to call them top heavy bottom heavy, and then I'm going to call it evenly balanced. All right. If I have a top-heavy function, we would describe that as the degree in the top is greater than the degree in the bottom. Do I have a top-heavy function here? Nope, I do not. If it's top-heavy, you will say that you have no horizontal asymptote. And if it is bottom heavy, let's see, that would be m is greater than n. This is pretty easy because you just say that y equal 0 is your horizontal asymptote. If it's evenly balanced, or n equals m, we will say that y equal a sub n over b sub m, or the ratio of the coefficients. So for a evenly balanced function, I would say that this ratio right here would be your horizontal asymptote. So let's look at our function that we just saw for horizontal asymptotes, and we see that he's evenly balanced. Get a different color pen here. Alright, so he's evenly balanced. So I take the ratio of coefficients. This would be, there's an understood 1 here. So for my horizontal asymptote for this function, y equals 2 over 1 is my horizontal asymptote. Alright, we're going to look at several of these so we can figure out what's going on. Alright, here's our first little function. We're going to find the vertical asymptotes. To find the vertical asymptotes, I set the denominator equal to 0. So, x squared plus 1, where does he equal 0? X squared equals negative 1. I'm not going to get any real answers for this. So I will say no vertical asymptotes. Let's check horizontal asymptotes. I check to see if it's top heavy, bottom heavy, or evenly balanced. This particular function is bottom heavy. Notice the degree in the bottom is bigger than the degree on top. Bottom heavy function, y equals 0 is horizontal asymptote. Done with this guy. Now we're getting ready to graph these things, and so what we're needing to know is where are these different asymptotes so that we can graph them efficiently. I need to find the vertical and horizontal asymptotes for this thing. I need to factor this to make sure he is reduced as low as he could go. This would be x plus 2, x minus 1. This is going to be x minus 3, x plus 2. Looks like I have common factors for this. So this basically is going to look like x minus 1 over x minus 3. Alright, vertical asymptotes. Set the denominator equal to 0 and solve for x. X minus 3 equals 0. X equal 3 is vertical asymptote. There's that one. Horizontal asymptote. Is this top heavy, bottom heavy, or evenly balanced? This is an evenly balanced function because the degree in the numerator is 1, the degree in the denominator is 1. So y equals the ratio of the coefficients, 1 over 1, 1, is horizontal asymptote. All done with this little fella. Alright, I'm going to find the vertical asymptote for this thing. I set the denominator equal to 0 and solve for x. X squared equals 3. Take the square root of both sides, remembering my plus minus case. This is plus minus square root of 3. Not a pretty number, but it still would be my vertical asymptote. So this right here are vertical asymptotes. I'd have one at positive square root of 3 and one at negative square root of 3. Horizontal asymptotes. Top heavy, bottom heavy, or evenly balanced. Degree in top is 1. Degree in bottom is 2. This is a bottom-heavy function. Y equals 0 is horizontal asymptote. All done with this little fella. Alright, I need to find the vertical and horizontal asymptotes of this guy. I looked to see if it has any common factors. If you were to factor this, you would have an x minus 2 term, which isn't going to cancel with that, so I'm good there. I just take the denominator, set it equal to 0, and say x equal -1 is vertical asymptote. Vroom. Then I'll go over here to my horizontal isotopes and see, is it top heavy, bottom heavy, or evenly balanced? This is a top heavy function, so my degree in the numerator is bigger than my degree in the denominator, which means that there are no horizontal asymptotes for this particular function. And I think that pretty much covers all our cases. We're going to be talking about slant asymptotes and graphing these rational functions next.